Hi, MC Bling Daddy here with the 11th and last video in the CBC Coding Engine series. This series is intended to introduce the coding engine, CE, for Minecraft, designed to assist in using high-level programming code in Minecraft by generating command blocks at a lower level that, in effect, carry out that code. Check out the previous command block coding or CBC videos for how command blocks can be created and organized to do this, or see video number 1 in this series to find out how to add the engine simply to your own world. In this video, we'll look at the execution of some more advanced pseudocode and take a brief look at the command block structures created to execute it. If you have questions about the functionality available in the engine, please see earlier videos in this coding engine series. Last time we looked at a demo using pseudocode that could be used to create a multiplex housing unit suitable for Minecraft player habitation. Please see video 10 in this series. This time we'll emphasize switches, creating a set of nested switches that extends the multiplex by adding doors, windows, and external stairs with railings. See the pseudocode presented in the comments section of this video. The main code for the construction is unchanged from the previous video, and you can refer to that pseudocode there. The difference is in the coding of sub S6. Which originally placed single wood plank blocks along the north side of each unit. S6 still only places single blocks at a time, but has a varied repertoire to create doors, windows, and stairs between stories in individual units. What you've been looking at is a test construction, with only one unit and 2 stories, made before the final multiplex run. It's clearer on the multiplex run, where you can see the parts of the structure that have been added. These are specified in the pseudocode. You'll see from the final multiplex run, though, that each story has essentially identical new structures: stairs, railing, gates, doors, and windows. Although the interior is a little sparse, it's ripe for an enterprising interior decorator to create some rooms. And, with the proper lighting and furniture, it can be used to view some beautiful sunsets. The exception that each story has essentially identical new structures is that only railings have been added for the roof story for safety. Now let's go look at some new command block structures. In previous videos, sub S6 was called from inside a loop over for loop variable b that set individual blocks in a row of blocks on the side of a unit. That hasn't changed. Let's look at the new pseudocode for sub S6. You can find it at the start of the comments for this video. It's basically all switches with nested switches deeper in. We already know S6 is used to insert blocks for all locations in all north rows of a unit, but the switches are used to determine the specific location of the next block to be placed. For example, C equals 6 when a wall is under construction, as opposed to a floor or a roof. A door is only placed in the first block in a wall's row, and that would be when B equals 1. But whether it is or not the bottom or top of a door, or just a plain wood plank is inserted, depends on the loop or layer, or level, however you want to think of it, L in a story when L equals 1 or L equals 2. So switch of L is embedded in switch of B, which is in turn embedded in switch C. And here's a view of the command blocks that have been generated for this pseudocode. The entry point for the sub is circled. Let's take a look at the outermost switch for C, and then how it's represented by command blocks. The typical switch has a spine of redstone wire that connects the test blocks so they operate simultaneously. For the typical switch case, such as C equals 7, that doesn't have complex code embedded, we can use the command blocks hanging off the end of the case to carry the commands we want to be executed for the case. As you see here, C = 7 extends off to one side of the switch spine. It ends with the command to transfer to the ESWC, or End Switch C, set point. C = 6, however, has an endpoint that initiates a new command terminus for commands that will be executed when C = 6 tests true. The engine has a setup function for altering the normally generated command blocks that occur at the end of a switch case to propagate the redstone signal to the newly created code terminus. You can find the new engine functionality in the description text box of this video. This terminus can be used as a new start point for creating new code execution lines for nested if tests, while loops, for loops, and switches, and individual commands that are to be nested inside of the switch case. We'll just be using it as a new spine for a nested switch. And all these functionalities, including nested switches, can be generated using the engine, of course, as have all the nested switches and commands in this sub. And what you're seeing here is all the case tests for switch of B along its spine. Some of these have embedded switches as well. Switches for the case C = 1 to 2 have a similar structure, but instead of hanging off to the right of the C switch spine, they hang off to the left of that spine. A couple of the cases of the B switch, B = 1 and B = 3 to 4, have embedded nested switches that depend on L, or the specific loop that's being executed. Well, that's about it for this series. I'd be curious if anyone has other ideas of processes in Minecraft that could be done starting from pseudocode besides building construction. Leave a comment in any case if you've been following along about what you've liked and what you haven't in this series. And, as always, thanks for watching.